This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will walk you through the solutions to exercise 8, questions 1 to 3, which focused on using for and while loops. What I have done for these first couple of questions is set up the script that will contain all our solutions. The editor is open, and you can see I have already added some comments to the top of the script, plus the clear all and CLC commands. Question 1, part A, was to write a for loop that multiplied all even numbers from 2 to 10, starting by defining our loop. We then define our loop counter variable x1. This will start at 2, go in steps of 2, and end at a value of 10. This therefore contains all the even numbers between 2 and 10. Then, within the body of the loop, we will calculate the required result, the multiplication of all the even values. We will call this result 1a. This is equal to the value of the previous iteration times our loop counter variable x1. I have left the semicolon from the end of this command intentionally. This is so we can see the returned results for each iteration. Before we can use this loop, we need to define the starting point of result 1a. This will be 1. Now running the loop, it returns the results 2, 8, 48, 384, and finally 3840. You can also use the command window to perform your own calculation to make sure that these are the correct values. Question 1, part B, was to carry out the same task but using a while loop. Returning to our script, I add a semicolon to the end of the function so it doesn't print all the values again, and we'll just display the final result from 1a. Now, we'll define our while loop. The condition to run our while loop is that while our loop counter variable x2 is less than or equal to 10, then it computes the multiplication. We call this result 1b and equate it again to a previous iteration times the loop counter variable. We then have to define x2 for each increment. Because we want even numbers, we set it as x2 is equal to x2 plus 2. Once again, we define result 1b as starting at 1, and our loop counter variable x2 as initially being set to 2. Finally, we end the statement and display the final result for 1b. We can then run our script again using the play button in the toolbar, and this returns result 1a and result 1b, which you can see are the same answer. Question 2a asks us to use the for loop that assigns the values 10, 20, 30, 40, and 50 to a vector. So, we'll define our for loop and then our loop counter variable m to range from 1 to 5. The reason we do this is that we are going to use m to put our values into a vector, i.e. m is going to be the index to our vector. The vector will be called result 2a, indexed with m, and then defining x3 to be the values we want to add to that vector. x3 is incremented by 10 on every iteration of the loop. Finally, we need to define the start of x3. We equate it to the first value of our vector, which is 10, and we are ready to run the script. You can see that we are getting the values we require in the vector. Question 2b was to do the same but using a while loop. So that's an input of while x4 is less than or equal to 50, then it should compute the result. Again, we index m and equate it to x4, which is defined as x4 plus 10 on every iteration of the loop. And when we're using the while loop, we also need to increment our indexing value m by 1 for each loop. For each iteration of the loop, we put a new value into the next element of the vector. Again, we need to define the variable x4 starting at 10 and the index m starting at 1. Running this gives us the same answer as part A, which is what we wanted. Question 2, part C, asks if there is a simpler way of doing this, avoiding loops. In this case there is. We could simply create this as a vector using an array. We could have entered the array by hand like this, since there weren't too many elements. We could also use a column vector. Or, alternatively, we could have used a linspace function. Running these from the script, we can see that they all produce the same result. Question 3 gives us a vector. Part A asks us to add all the elements within the vector together. The vector x contains the elements 1, 8, 3, 9, 0, and 1. Using a loop, then defining our loop counter variable n to start at 1 and then count through all the elements in x. Since there are only 6 elements in x, we can simply type 1 to 6, but instead we can issue the length command to get the length of x. It is good practice to use this because you might want to change the number of elements in x and not have to worry about remembering to change other parts of the script. Within the for loop, we want to add up all the elements, assigning them to a variable called mySum. And mySum will equal the value of the previous iteration plus the new value, which is x of n. We end the loop, adding a comment stating that this is a summation formula, and also remember to define mySum as starting at a value of 0. You are told that you can use the built-in functions sum and cumSum to check your answer for this question. We can use the display command to display our calculated sum and display the sum used in the built-in sum function. We now can run the script and check we have the right result. You can see that our summation using the for loop and the MATLAB summation produces the same answer. We now move on to doing a similar thing for part B, but this will be a cumulative sum. Again, we're told to use the for loop, so we define our for loop. But you can see with a cumulative sum that instead of the answer being a single scalar value, it's actually a vector of values. We are given the result we expect to see, and this is 1, 9, 12, 21, 21, 22. Our loop counter starts at 1 and continues for a length of x. And since our cumulative sum variable is a vector, we will index it with loop counter n, and that will equal the sum of the previous values plus the new value. However, if we run this as is on the first iteration of the loop, the first value of the cumulative sum will try and access the 0 element, which does not exist. So, for our cumulative sum vector, for the first value, we will equate it to the first value of x. and we'll start our sum from the second value of x. Finally, we can simply copy and paste the display commands below the function, obviously altering the term sum to CumSum so it compares our cumulative sum with MATLAB's. We can now run our script again, and it returns the same vector for both our CumSum and MATLAB sum.
This production is copyright the University of Edinburgh.